This is Algebra 2, Unit 8, Lesson 5. And in this lesson, we're going to talk about operations on functions. We've already talked about how to sub into a function, like if I give you this function f of x equals x squared minus x minus 6, and I ask you to find f of 1, we know that that means we plug 1 in for every x in the function, and then we just simplify. And then we've talked about composite functions where we have a function within a function, where we might say f of g of x, find f of g of x, and we would plug the g function into the f function, or g of f of x means plug the f function into the g function. So we've done stuff like that. But what we haven't done is operations on functions, and I think this is even easier than composite functions or any of the other plugging in functions. If we have two functions, all of the math operations work on those functions. So and this is, we could have more than two functions. It doesn't have to just be two functions. We could do this with any number of functions. We can add functions together. We can subtract functions from each other. We can multiply functions together. We can divide functions by each other. So we can do all four of the math operations. So if they give us something like this, where it says f of x plus g of x, all that means is find f of x, write it down, and then add g of x to that. So the f of x function is x squared minus x minus 6. The g of x function here is x plus 2. All they want us to do is add those two functions together. So to add those two functions together, all we have to do is add like terms. So I've got x squared, negative x plus x is 0, negative 6 plus 2 is negative 4. That's all they want you to do. F of x plus g of x is x squared minus 4. You don't have to do anything else. A common mistake here is students see that and they say, oh, that's difference of squares. I can do x plus 2x minus 2. They're not asking you to do that. They don't want you to factor. They don't want you to do anything else. They just want you to find f of x plus g of x, add them together, you're done. For this one, f of x minus g of x, I'm going to take the f function, x squared minus x minus 6, and I'm going to subtract the g function from that. So if I do that, I have to understand, and this is probably the most commonly missed one because students forget to distribute that minus sign. I have to make sure that I subtract both terms of the g of x function, or all terms of the g of x function. Sometimes they may have more than two terms. So this would be x squared minus x minus 6 minus x minus 2 if I write it out. Now, I don't need to do this step. I could go straight from here to the answer. X squared doesn't have any like terms, so I've got x squared. Negative x minus x is negative 2x, and negative 6 minus 2 is negative 8 for my answer. Here I have g of x minus f of x, so I'm going to have the g of x function, x plus 2, minus the f of x function, x squared minus x minus 6. And when I do that one, I have x minus negative x, which is 2x. 2 minus negative 6 is a plus 8. And then the minus x squared would be the last term of that one. You could write this one in any order. You could say that that's negative x squared plus 2x plus 8. You don't have to have it in the same order that I have it in. You just have to have the sign in front of the correct numbers. Here, f of x times g of x. I'm going to take the x function, x squared minus x minus 6, and multiply the x plus 2. And so in doing this, I have to do the distributive property several times. I'm going to take x squared and multiply it by both of these terms. X squared times x is x cubed. X squared times 2 is positive 2x squared. Then I take the negative x and multiply both terms. Negative x times x is negative x squared. Negative x times 2 is negative 2x. Then I take the negative 6 and multiply by both terms. Negative 6 times x is negative 6x. Negative 6 times 2 is negative 12. Then I add my like terms. So I would have x cubed plus x squared minus 8x minus 12 to finish that problem off. The board was getting a little too crowded, so I just took the last three examples and made a little more room for us. For the next one, f of x over or divided by g of x, I'm going to take the x function, x squared minus x minus 6, and divide by g of x, which is x plus 2. Now, if I can simplify that, I should simplify all the way. So I'm going to try and see if it'll factor. Are there factors of 6 that subtract to give you 1? There are. X, and a 3 and a 2. I have a minus 3, a plus 2. and then that's over x plus 2. So hopefully you notice those cancel, leaving me with an x minus 3. So if it can be simplified, I would simplify it completely. For the next one, g of x over f of x, this time it's backwards. The g of x is on the numerator and the f of x is on the denominator. My factoring here is still the same. I should still simplify. The x plus 2 still cancels out, leaving me with a 1 over x minus 3. You need to understand you do not need the 1 here because it would be on the denominator, and that's just the same as having the x minus 3 on top. Here you do need the 1 because the numerator had everything had canceled out, so you do need the 1 on the top there. And then the last example, this is called scalar multiplication. It's really just the distributive property. We're going to take 5 times the g function plus 2 times the f function. We'll add the like terms together. So 5 times g of x would be x plus 2, plus 2 times f of x would be x squared minus x minus 6. And then I'm just going to do the math by distributing. So I have 5x plus 10 plus 2x squared minus 2x minus 12. And then I add my like terms. 2x squared plus 3x minus 2 would be my final answer. So nothing real significant in this section, just something that you need to know can be done. I don't think you've probably done this in Algebra 1 at all, so we'll get a little practice with this and then we'll move forward with functions.